This video is for solving a system using a technique known as elimination. Now, elimination is a word. If you think about it, eliminate means to get rid of something. And that's exactly what we do in this method. All right. So the first thing that we're going to do is we're going to write both equations in standard form. That would be ax plus by equals c. Or in other words, make sure your x's are first, your y's are second, you have an equal sign and then a number. We're going to line up both equations so the x's line up, the y's line up, the equal signs line up, and the numbers line up. Then we're going to look at the two equations. So we're going to determine by looking at them which variable to eliminate. Specifically, what I'm looking for is I'm looking for opposites. I want two values of, or two coefficients of a variable to be opposites. What if I don't have any opposites? Well, if you don't have any opposites, we're going to adjust by multiplying one or both equations in order to get a pair of opposites. All right, so after I get opposites, what I like to do is I call this smash. I'm going to merge the two equations together, allowing for that one variable to eliminate. Solve for the remaining variable. Substitute the result from that solving in step 4 into an original equation. Solve for the remaining variable or the other variable. And then don't forget, we're still solving a system, so my solution is an ordered pair. All right, so let's take a look and see what I'm talking about with those directions. I have two equations. Both of them have the x's lined up, the y's lined up, and the equal sign and the numbers lined up. Everything is lined up. If you notice, I have, for my y's, I have opposites for coefficients. This 9 and this -9 are opposites. So if I take these two equations, and because they're opposites, I smash these two equations together, these two opposites will cancel, leaving me with -2x is equal to -18. All right. Now, I have to solve this for x. So if I solve for x, I have divide by -2, and that leaves me with x is equal to 9. But now I need to go back and find y. Notice when I smashed, I marked off those y's, but you can still read them. And the reason why I wanted to make sure I did that is because I'm going to take this x value that I just found and plug it in here. So I have 6 times 9 minus 9y equals -27. I could have plugged it into the other equation as well. This gives me 54 minus 9y equals -27. I'm going to subtract 54 from both sides. And that leaves me with -9y is equal to -81. Divide by -9 to solve. And I find y is also equal to 9. Take the x and the y, write them as an ordered pair in alphabetical order, 9, 9. And that's my solution to this system. Now, notice we would use this technique when we didn't have substitution set up. So let's look at another scenario. All right, so if I look at these two equations, I don't have any coefficients of a variable that are opposites. But I feel like that's what I want to eliminate. And it makes sense. Because what I need to do first is I'm going to rewrite this system by adjusting one of the equations to make the 6x become its opposite. All right, so to do that, I know I am going to multiply this bottom equation by -1. So let me recopy the system now. It's 6x plus 8y equals -18, and distribute this -1, which would be -6x minus 10y equals positive 18. Because I have opposites, I'm ready to smash, and those x's eliminate. That's why it's called the elimination technique. This leaves me with negative 2y equals 0. And if I divide by negative 2, 0 divided by anything is 0. I take that 0, I go back to one of my original equations. For this one, I'm going to go back to the top one. I have 6x plus 8y, but I'm going to put a 0 in there for y, equals negative 18. This leaves me with 6x, 8 times 0 is 0, so 6x equals negative 18. I'm going to divide to solve. Divide by 6 there. And I get x is equal to negative 3. When I go to write my ordered pair solution, remember alphabetical order. So the answer here would be negative 3, 0. Okay, couple more scenarios here for you. Let's say on this one I look at it. Now, what would you eliminate? I could eliminate x's by multiplying the bottom equation by 2. I could eliminate the y's by multiplying the bottom equation by negative 4 to create opposites. I'm going to choose to multiply by a positive 2 and eliminate the x's. Either way would work. So I'm going to rewrite my system. 20x minus 4y equals negative 16. And negative 20x minus 2y equals 22. Because I have opposites, I'm ready to smash, and these x's eliminate. I'm left with negative 6y is equal to 6. If I divide to solve, I get y is equal to negative 1. I'm going to take y and substitute it into an original. This time, let's do the bottom equation. So the bottom equation is negative 10x minus y. But look at what that's going to be. It's going to be minus negative 1 equals 11. If I clean this up, I have negative 10x plus 1 equals 11. Minus a negative is the same as addition. I'm going to subtract 1 from both sides to move it. And that leaves me with negative 10x is equal to 10. Divide to solve. And I would get x is also equal to negative 1. I'm going to write this ordered pair as negative 1 in alphabetical order, x comma y. All right, so this last example would be the most complicated that you would face here. All right, so on this particular problem, I notice that nothing seems to be lined up to eliminate. I'm going to go ahead and eliminate y's. I don't have any particular reason for it. I'm just choosing to eliminate y's. So I see a 5y and a 7y. I need to make those y's, the coefficients, become opposites. All right, so I'm going to multiply this top equation by 7. That would give me 35y. If I do that, I'm going to multiply this bottom equation by negative 5. And let's see what happens. If I did this right, then my y's should be ready to smash and eliminate. So let's see, 7 times negative 5x, that's negative 35x, plus 35y. And let's see, 7 times negative 15 would give me negative 105. On the bottom, negative 5 times negative 4x is 20x. Negative 5 times 7y would be negative 35y equals, notice how those y's are opposites of each other. And then we have negative 5 times negative 18, which would be a positive 90. I'm ready to smash because those y's are opposites. I'm left with negative 15x is equal to negative 15. Divide to solve, and I get x is equal to 1. Substitute back in. Let's substitute into the top equation. No reason, I just chose that. So I've got negative 5 times 1 plus 5y equals negative 15. Or negative 5 plus 5y equals negative 15. I'm going to add 5 to both sides. That leaves me with 5y is equal to negative 10. Divide to solve, and I get y is equal to negative 2. Write this as an ordered pair, 1, negative 2, because x comes before y. Hope this helps. Let me know if you have any questions.